Okay, this is lesson 8.4, which is solving any quadratic. So let me review two different quadratics for you. First of all is the ones where there's a greatest common factor. So looking here, we see that there are two terms. These are most confusing. And what we need to do is we need to make sure that we factor out an x out of both of them. So maybe you like putting them in the box. This is 5xx. This is 5 times 10 and an x. They both have a 5, so we'll factor out a 5. They both have an x, so I'll factor out an x. What's left is an x plus 10. Could do that. Option 2 is you see that they're both divisible by 5. They're also both divisible by x. So you can divide that out and write what's left. Now that you've factored it and it's set equal to 0, you can use the zero product property. Divide by 5 on both sides. 0 divided by 5 is 0. Subtract 10. And our solutions are negative 10, 0. Number 2 is a difference of squares. If you remember, difference of squares are things in the form where it's a squared minus b squared. Where if you look at, say, this term here, we know that's a perfect square because 5 times 5 is 25. We know this is a perfect square because 2x times 2x is 4x squared. So when you see that, then it's going to be equal to a plus b times a minus b, which means, looking at the first term, this is 2x times 2x will be 4x squared. Looking at the last term, this is 5 times 5. And so, one's addition, one's subtraction, so that the middle term cancels out. Since these are set equal to 0 and they are a product, we can set them both equal to 0 and solve. Divide by 2, x equals 5 over 2. Add 5, divide by 2, x equals 5 over 2. Oh, sorry. Oh, this should have been a plus sign, so that this is a minus sign. Sorry. X equals negative 5 over 2 and 5 over 2. The other thing that's in today's lesson is the idea of solving for area problems. We're going to use using solutions to quadratics. So quickly, let's warm up. We need to translate each of these into a math equation. 4 more than twice a number. 4 more goes out at the end, then twice a number. 8 less than 3 times a number. 8 less goes at the end, then 3 times a number. The height is 4 less goes at the end, then 10. So h equals 6. The height is 4 less than the width. So let's do some problems. The area of a triangle below is 8. Area is 8. What is the length and width of the rectangle? That's what I'm solving for. So if we look over here, we see the dimensions of the rectangle are w and w plus 2. So the area of this rectangle is w squared plus 2w. That's the area of the rectangle given its dimensions. But we also know that the area is 8. So I'm going to substitute 8 in for a. Now, let's ignore the fact that this is an area problem. If I asked you to solve for w, you would subtract 8 on both sides so that it's set equal to 0. Then you would factor Again, so you can use the zero product property. Two numbers that multiply together to get 8, 4 and 2, that combine to get a positive 2. Again, if I asked you to solve for W, you would set W plus 4 equal to 0 and W minus 2 equal to 0. Subtract 4 on both sides. W equals negative 4. Add 2. W equals 2. We did all that, but what we really did is we figured out that the width is negative 4 or 2. Now let's think about that. The width is negative 4. Does it make sense for the width to be negative? The answer is no. Distance must be positive. We would never say that our height is negative 4. That's crazy. Okay? So we actually know that the width is going to be 2. The length will be W plus 2, which is 4. The units are inches. So the length is 4 inches and the width is 2 inches. Kind of cool, right? Let's look at number 6. The length of a rectangle is 12 meters more, plus 12, then 3 times its width. Keep reading. The area is 15. What is the length and width of the rectangle? Now, if I were to draw this box, I'd know that the length is 3W plus 12. Does it say anything about the width? Since it doesn't, we actually are just going to put it there. That's the way this works. You just put it there if they don't define it. Area, 3W squared plus 12W. So the area is 3W squared plus 12W. We also know that the area equals 15, so we will substitute. Since we have to solve for W, we need to set this equal to 0, so I will subtract 15 on both sides. Now I need to factor this. I recognize that they're all divisible by 3. 3 times W squared plus 4W minus 5. Now, I need to factor. Two numbers that multiply together to get me 5, 5 and 1, combine to give me a positive 4, positive 5, negative 1. I'm going to set each of these equal to 0. You might ask, what about the 3? Well, if this equaled 0, it'd be 3 times 0, which is 0. If this equaled 0, it would be 3 times something times 0, which is still 0. So we actually are just kind of ignoring it. W equals negative 5. W equals 1. The width is negative 5. The width is negative 5. That doesn't make sense. Width can't be negative. The width is 1. Now, the length is 3 times the width plus 12, which is 3 plus 12, which is 15. And that's area.